Okay. Right. Yeah. Welcome to this YouTube RRR series. And in this RRR YouTube series from StudyMEDIC StudyMRCOG group, we will be discussing on the topic inferential tests. Myself, Dr. Avinash, one of the mentor at StudyMEDIC group, dealing with biostatistics and research methodology. Now, we will see in this RRR series, we will be discussing on what are the inferential tests that are used to check the hypothesis and to find the significance of the effect of the study. What are the different types of these inferential tests? And what assumptions need to be met if we have to select a type of inferential test in order to use a particular inferential test in a particular situation. Now, what are these inferential tests? These inferential tests are used to find if the effect observed is due to chance or not. Selection of these inferential tests depends upon the type of the effect observed, objective of the study, selection of the inferential tests depends upon the type of the effect observed, the objective of the study, and our hypothesis. Now, which assumptions are to be checked for selection of tests? We shall see. Now, one, we need to look at what type of variables are there in the study. Two, whether this variable is continuous variable or categorical variable. Continuous variable means those variables which can assume any value in the spectrum, whereas categorical variable are non-numerical qualitative variables. Then how many number of variables are there? Is it one? Is it two? Or is it more than two? For example, groups. If there are one groups, if there are two groups, or if there are more than two groups. Whether these groups are dependent upon each other or independent, whether these groups are related to each other or unrelated, are paired or unpaired, are independent of each other, or mutually exclusive of each other. We need to look at that. Then we need to look at the type of the distribution of the data representing the variable, whether it is normally distributed or not normally distributed. And other important assumptions, which we are not trying to cover all the assumptions, but we will try to cover only simple assumptions. However, not only this, many other assumptions needs to be met statistically in order to select a particular test. All other assumptions when met, and if the data are normally distributed, we select a particular type of the test called as the parametric tests. Now, if some of the assumptions are not met, and if the data is not normally distributed, then we select a type of the test called as the non-parametric tests. So there are two types of tests: parametric tests, which are selected when all other assumptions are met and the data is normally distributed. The non-parametric tests, which are selected when assumptions are not met and the data is not normally distributed. Now, let us see these tests. Suppose in a particular study, they wanted to find the time of cesarean section is delayed in high risk group when compared with low risk group. Now, what is the variable that we are observing here? It is one is the time of cesarean section. Okay, and that is the continuous variable. The time of cesarean section is a continuous variable, and the groups in which this time of cesarean section is recorded is one is in the high risk group, okay, and another one is in the low risk group. Now, what are they doing? What is the objective here? They want to compare the time duration of cesarean section done in low risk group versus high risk group. That means in this study, they are trying to find out the significance of the difference in mean time of the cesarean section between high risk versus low risk group. If there is a difference, is it higher in high risk group? And if this difference is significant or not. This is the objective. Now we can see it's continuous variable, time of cesarean section, and it is between two categorical groups, that is low risk versus high risk, and both are mutually exclusive groups. That means population present in one is not similar to the population present in the another group. That means they are unrelated, unpaired, mutually exclusive, independent groups. So when we want to find out a significance of difference in mean between two mutually exclusive groups, and if the data is normally distributed and it meets all other assumptions, we use a parametric test called as the independent student t-test. Whereas when the data does not meet other assumptions and is not normally distributed, we use what is called as the Mann-Whitney U-test, which is then alternative non-parametric equivalent to independent student t-test. Independent student t-test sometimes is also called as the t-test or unpaired test t-test. All are same. Now we will see if in a study they wanted to find out the hemoglobin level, which is a continuous variable, whether it has improved. That is the objective they want to see. That means they want to see the difference before and after the cesarean section. That means hemoglobin percent is a continuous variable whose value they are trying to find out before cesarean section, and they are trying to find out what happens to this hemoglobin value after cesarean section, whether it is decreased or increased, etc. Now here they are trying to find out the significance of the difference in a continuous variable between two categorical groups, but these are related groups, paired groups. They are not mutually exclusive, right? Because the women who are present in the before cesarean groups, they are similar to the women who are present in the after cesarean group, after cesarean section group. That means these two groups are paired groups. So when we want to find out significance of a difference in mean of a continuous variable between two paired groups, the classical is before and after studies, we do what is called as paired t-test. And when it is normally distributed, we do the parametric test called as the paired t-test. The non-parametric equivalent to this paired t-test when the data is not normally distributed is Wilcoxon signed rank test. So one can see here that the hemoglobin has decreased after cesarean section, the mean hemoglobin level, and the mean difference is on an average, it is around 2 plus or minus 0.2 is the standard deviation, and the p-value after the test is less than 0.05. It indicates the finding is significant. That means hemoglobin level is significantly reduced after cesarean section. That can be our conclusion. And which test do we have used? Paired t-test if this data was normally distributed, and Wilcoxon signed rank test if the data was not normally distributed. Now, in another study, if they wanted to find this hemoglobin level, the same hemoglobin level, is it lower in eclamptic group when compared to pre-eclamptic or normal pregnancy? They wanted to find that. Okay, that means here you can see three groups: pre-eclamptic group, eclamptic group, and in normal pregnancy. Whether how is this hemoglobin level varying? That means a continuous variable, the mean of which is different in different groups, and they want to find out the significance of the difference in mean, whether it is varying in more than two groups. So categorical independent variable are more than two. You can see the normal pregnancy is one group, pre-eclamptic women are one, and eclamptic women are. Now you can see all are independent groups. All are independent groups, mutually exclusive groups, and they are unpaired groups. So in such a situation, when one wants to find the significance of the difference in means of a continuous variable, more than two mutually exclusive groups, and see how much it varies, whether it is significantly varying or not, then, and the data is normally distributed, we use what a test called as a one-way analysis of variance test. That is called as a one-way ANOVA. And if some of the other assumptions are not met, and the data is, if not normally distributed, the non-parametric equivalent that we use to ANOVA is Kruskal-Wallis test. Kruskal-Wallis test. Okay. Now you can see the p-value here is significant, less than 0.05. We consider it as a significant finding. And you can see significantly the hemoglobin level is reduced, varying and reduced in eclamptic women compared to the others. So till now we studied unpaired t-test, paired t-test, and analysis of variance. All these three tests are dealing with finding the significance of the difference in mean of a continuous variable, either in two mutually exclusive groups, that is t-test, and Mann-Whitney test, and more than two is ANOVA and Kruskal-Wallis test, and two paired groups, and that is the paired t-test and Wilcoxon signed rank test. Now, in a study, they wanted to find if type of delivery is associated with anemia. So the objective is to find whether the type of delivery. You can see the type of delivery can be either spontaneous vaginal delivery or lower cesarean section, lower section cesarean section, right? Now this type of delivery is a categorical variable. Whether this type of delivery is associated with the status of anemia. Now status of anemia, normal means less than, more than the normal range. And the anemic means hemoglobin less than the normal range. Now again, whether the person is anemic or not is a categorical variable. So here, the variables are two categorical variables. One categorical variable is type of delivery. Another categorical variable is whether the person is anemic or not, status of anemia. Now we want to see whether type of delivery is associated with the status of anemia. Or if you want to check how the type of delivery is related to the type of status of anemia, or if you want to see if the type of delivery is independent of the status of anemia. So three conditions. One, you want to check the association or the relationship, And another condition is if you want to check if one categorical variable is independent of the other categorical variable. Or suppose the observed frequencies are 70% of the normal undergo spontaneous vaginal delivery, and around, let us say, 30%, the rest 30% undergo, 20% undergo cesarean section. Whereas in anemic, 70% undergo cesarean section and 20% undergo spontaneous vaginal delivery. Now this is the observed frequency. What is the expected frequency? Suppose the expected frequency was 50-50. Suppose expected frequency. Now if you want to find out, is there a difference in this observed frequency versus the expected frequency? That is another condition. Then also we can do this test. So we do what is called as the chi-square test. So when do we do this chi-square test? One, if you want to find out if one categorical variable is associated with the other categorical variable, that is type of delivery, is it associated or related to type of anemic status? Or if one categorical variable is independent of the other categorical variable, for example, if type of delivery is independent of the anemic status, or to find out if there is a difference in observed versus the expected frequency of type of delivery in different normal versus anemic. In all these three conditions, we do what is called as chi-square test. Since this test already deals with categorical variables, it is already a non-parametric test. Now, when do we do chi-square test? That is when the total number of sample is more than 20 or cell count is always more than 2, right? And cell count percent is always more than 5%. Now, if total count is less than 20, then we cannot do chi-square test. The more robust alternative to chi-square test is the Fisher's exact test. Or if any one cell also contains a cell count of less than or equal to 2, or if the frequency is less than 5% in at least more than 25% of the cells. In all these three conditions, the alternative to chi-square test is the Fisher's exact test. So chi-square test is done to find out the association or relationship between one categorical variable with the other, or to check if one categorical variable is independent of the other. And the alternative is the Fisher's exact test, when the sample size is low or the cell count is low. Now, in a study, they wanted to find if relationship between BMI and BP is there or not, one. And they also wanted to find what is the strength of this relationship and the direction of this relationship. Now, the BP is a continuous variable and BMI is also a continuous variable. That means they want to find out the relationship or association between two continuous variables, that is BP and BMI. That means they want to find as BP increases, what would be happening to the BMI? Whether it also increases, whether it decreases, or it has no relationship. That means, and when these two are continuous variables and normally distributed and linearly associated, then the test that is done to find out the association between two continuous variables is Pearson's correlation test. Now, if that one of the continuous variable or both are not normally distributed, or if one of the variable is an ordinal variable, then we can go ahead and do the non-parametric equivalent of the Pearson test. That non-parametric alternative equivalent is Spearman's correlation test. Here, you can see that we get a value called as the R value. Now, R value is the coefficient of correlation. R value is the coefficient of correlation. Now, it can extend from -1 to +1. If the R value is +1, it is a highest possible positive association that can be found between two continuous variables. If the R value is -1, that is the highest possible negative association that can be found. If the R value is near 0, it means the correlation is not much. So R value, which is the coefficient of correlation, is used to find out the strength as well as the direction of the association. And here we always presume there is no cause and effect relationship between these two variables. One is never a cause of the other. While doing this test, we don't presume that. Now, how do we find out the strength as well as direction? The direction of the association is found by the sign that is there, whether it is plus or minus R value. If it is plus, the sign, the association is positive, means as BP increases, BMI increases. If it is minus, the association is negative. For example, as iron increases, TIBC decreases. Now, how do we find out the strength of the association? Is by the R value itself. If the R value is more than 0.7, the association is strong. If the R value is between 0.5 to 0.7, the association is moderate. If it is between 0.3 to 0.5, the association is weak. And when the R value is less than 0.3, the association is very weak. A strong association can be statistically not significant, which is determined by the p-value. And even a weak association can still be significant if the p-value is less than 0.05. So we should not confuse the coefficient of correlation with the significance of the test. Now you can see when we plot BP against BMI, they become the bivariate variables. So this plot is called as a scatter plot, which represents the relationship between two continuous variables. And you can see as such, it is increasing and the scatters are closely associated. And it is positive. As one increases, the other increases. Now, how would a negative association look like? It would be somewhat like this. As one increases, the other decreases. Negative association would somewhat look like this if I have to group the clusters. For example, iron and TIBC. Now, what is the other condition in which we find out when to use this Spearman correlation test? Now here you see, in a study, they want to find out if relationship between BMI and BP, but you can see here, not BMI and BP. Here, you want to find out the relationship between the socio-economic status, and hemoglobin percentage. The socio-economic status and the hemoglobin percentage. Now, what type of variable is hemoglobin percentage? It is a continuous variable. But whereas the socio-economic status, poor, middle class, rich and very rich, if you are to group them or grade them or rank them, then it becomes an ordinal categorical variable. Now here, one of the variable is ordinal, then we can do Spearman's correlation test. So if one want to find out the relationship or association between an ordinal and a continuous variable, or if one of the continuous variables is not normal distributed, both are not normal distributed, then we can go ahead and do this Spearman correlation test. Now, when do we progress ahead and continue to use regression analysis? Mathematically, regression is similar to the correlation. However, before doing the correlation regression, we need to assume that one is the cause of the other. That means the cause and effect relationship needs to be assumed, and there should be a biologically plausible explanation if you have to assume that. Scientifically possible hypothesis also should be there. Now, for example, when we do an association, it can give association between even non-causal variables. For example, when an association test is done between IQ versus the foot size, the IQ versus the foot size, they found out very good, strong, positive correlation. But does it mean foot size is responsible for IQ? No. As the baby grew, so does the brain size, so does the foot size. So you can see mere association does not always mean cause-effect relationship. But when we have a biological plausible scientific explanation to presume one is the cause and another is the effect of it, then we can go ahead and do inferential test ahead and find out what is the effect of this one variable on the other. Means every unit change in one variable, how much quantified, we can quantify how much the change will occur in the another variable. So there are cause and effect variables. Means here one variable is a dependent variable and the other variable is independent predictor variable. Now, for example, in a study, if you want to predict glomerular filtration rate from creatinine, now you can see the glomerular filtration rate becomes the dependent variable and creatinine is the predictor variable, or that is the independent predictor variable. Independent variable here is also called as the predictor variable. Now, what type of variable is this dependent variable when we put it as in Y, and independent predictor variable when we calculate it as denote it as X? So what type of variable is this GFR? It's a continuous variable and it is a dependent variable. What type of variable is creatinine? It is also a continuous variable and it is a predictor variable. So in this situation, when we want to predict or find the effect of one on the other, that means if you want to predict GFR from creatinine, or if you want to quantify, one is the predict, or if you want to quantify the effect of change in, for example, creatinine on GFR. So it means a unit change in creatinine, how much is the change observed in GFR? In both these conditions, or if you want to find out the effect of one on the other, in all these three conditions, so predict, quantify, find the effect. In all these three conditions, we can do regression. Now here, what is the dependent variable? Dependent variable is continuous. Independent variable is also continuous. So in such a case, we do what is called as the simple linear regression. Okay. So here you can see dependent variable is also continuous and independent variable is also continuous. And mathematically, a line of best fit is plotted between this, and a straight line equation mathematically is y is equal to ax plus b. Y is the dependent variable and a is the slope of the curve, and x is the independent predictor variable and b is the constant where the line meets the y-axis. Okay, how much is that? Systematically more or less, that is the b. So when the dependent variable is continuous and the independent predictor variable is continuous, if we have to do regression, and if these continuous variables are linearly related and normally distributed, we do what is called as a simple linear regression. Here, as we can see, we get a value called as the R square value. Similar to the R value in Pearson's or Spearman correlation, which is called as a correlation coefficient, here we get R square value. What is it? It is a coefficient of determination. So what exactly does it determine? It determines the effect. Now, for example, R square is 0.91, means 91% of the change observed in GFR can be explained by the changes seen in creatinine. The rest 9% of the change that is observed in the GFR could be due to something else. Or it can also be a test for fit to the model, whether the model is fit enough. Okay. So R square value is coefficient of determination. Now, in a study, if you are to do this regression, in study, for example, they wanted to quantify the effect of change in hemoglobin, right? So a unit change in hemoglobin, how much change does it cause to HbA1c on time of cesarean section? Now you can see one is change in hemoglobin, another one is HbA1c, on time of cesarean section. So they want to see whether these two variables, variable 1 and variable 2, whether they caused any change in variable y. So the dependent variable is the time of cesarean section, and the independent variables are change in hemoglobin level and the HbA1c levels. Now the time of cesarean section is the dependent variable, it is continuous variable. Independent predictor variables, there are more than one. Either it can be continuous variables or categorical variables. We should not be worrying about it. But if the dependent variable is continuous, and if there are more than one or two independent predictor variables, and if you want to quantify the effect of these predictor variables or independent variables, then we go ahead and do what is called as multiple regression test. So when is multiple regression test done? So when there is continuous dependent variable and there are more than one independent categorical variable. And this independent categorical variable can be continuous or categorical or either or both. It should not matter. Okay. So that is when we do multiple regression test. Now a simple linear regression test is done when the dependent variable is continuous and there is only one independent variable. Whereas a multiple linear regression test is done when the dependent variable is continuous and there are more than one independent variables. Now, in a study, they wanted to find the effect of type of presentation on type of delivery. Now, what is the dependent variable? The dependent variable is the type of delivery, and the independent variable is the type of the presentation. Now, if the type of delivery is cesarean or spontaneous vaginal delivery, now it is a type of categorical variable. So the dependent variable here is the categorical variable. Independent variable is also categorical. It can be continuous also. We should not worry about that. Excuse me. Now, when the dependent variable is categorical and the independent variable is either continuous or categorical, and you want to find out the effect of a independent variable on a categorical variable, dependent variable, then we do what is called as logistic regression. Then we do what is called as the logistic regression. So, to summarize, when do we do linear regression? So, y is equal to ax plus b. For example, if you want to predict GFR from creatinine. So you can see GFR is a continuous variable and there is only one independent variable. So we do simple linear regression. Now, if you want to find out the effect of not only creatinine, but also age, probably also gender, etc., or race on GFR. So you can see the dependent variable is continuous, but there are more than one independent predictor variables. Then we do what is called as multiple regression, multiple linear regression. Okay, so then, for example, outcome of pregnancy is a dependent variable. If you want to predict the outcome of pregnancy using the age or let us say hemoglobin concentration or anything else, etc. Now, what is the dependent variable? Outcome is the dependent variable and it is categorical variable. And when the dependent variable is categorical variable, we do what is called as logistic regression. This is in a simple way to term when do we use this simple linear, multiple linear and logistic regression. Now again, if you are to summarize, when we want to find out the significance of the difference between a continuous variable between, let us say, I have not told that here, one group, and we compare this variable with the population. Then we do what is called as one sample t-test. The alternative is the one sample Wilcoxon test. Okay. Now, if you want to find the significance of difference in the continuous variable in two groups, and these two groups are independent, mutually exclusive, then we do, it is called as the student t-test. The alternative to is Mann-Whitney U-test. Now, if you want to find out the significance of the difference in continuous variables between two paired groups or related groups, then we do what is called as paired t-test. The alternative to paired t-test is the Wilcoxon sign rank test. When we want to find out whether the continuous variable is varying in more than two mutually exclusive groups, then we do what is called as analysis of variance. The alternative to is Kruskal-Wallis test. Now, when you want to find out if the continuous variable is different or varying in more than or equal to two paired groups, then we do what is called as repeated measures analysis of variance. Now, if you want to find out whether the categorical groups are varying between two or more paired groups, then we go ahead and do a different test, which is not related to here. Now, if you want to find out more about this, please do share and subscribe to our channel and also our groups. So when do we use these categorical, if the categorical variables, whether they are varying in more than two paired groups. Now, if you want to find out association between two continuous groups, association between two continuous variables, then we do Pearson correlation test. The alternative to is Spearman correlation test. When you want to find out the association between two categorical groups, who are more categorical groups, then we do what is called as the chi-square test. When the sample size is less, we do what is called as the Fisher's exact test. So these are the different tests that we do select based on the objective type of the variable and whether it is normal distributed or not. Right. So this is the summary of what we have discussed today. So we discussed when to choose a particular inferential test, which depends upon the type of the variable, whether it is continuous or it is categorical, whether it is normal distributed or not normal distributed, whether the categorical groups are 1, 2 or more than 2, whether they are related or mutually exclusive, and what is the objective. I hope you are largely benefited by this session on inferential tests. And you can see here, we not only cater to MRCOG, but also cater to MRCPI, MRCS, and other courses. And if you have any queries and interest, please do contact to these contact numbers which are given here. And if you subscribe, I'm sure you will get to all these detailed live session recordings, live sessions, session recordings, preparatory videos, audio podcasts, mock tests, and vast access to the resources and library and individual group reactions, one-to-one interactions, and you will be hugely benefited. I can assure you that. And thank you for listening to this. If you have any doubts, please do share it on the comments. Do like, share, and subscribe our StudyMEDIC YouTube channel, RRR Series, and also subscribe to our group, StudyMEDIC group. Thank you. Have a good day.